A second case from this period was Lise Meitner. Meitner, like Blau, was one of the first women scientists to get a PhD. This really only was possible in Germany and the German-speaking countries around the turn of the 19th to the 20th century. Meitner was indeed the second woman to get a PhD from the University of Vienna in 1905. Max Planck was reluctant to let women attend his lectures. In fact, Meitner was one of the first he permitted in. But within a year, he had made Meitner his assistant, an assistant in the German sense, which was a kind of assistant professor, and therefore already beginning the slow and difficult march up the hierarchy of professorships. In 1912, she was working with Otto Hahn, and the two of them moved to this new institute in Dahlem, the Kaiser Wilhelm Institute, which is now called the Max Planck Institute. But the Kaiser Wilhelm Institute was this new institute for science, and Meitner and Hahn began a very long and very productive collaboration. In 1913, at the age of 35, she finally got her first paid position. This was really a slow process, and there were only a handful of women who were promoted to full professorships in Germany in physics, but she was one of the first. After 1932, when the neutron was discovered, a particle roughly like the proton that's located inside the nucleus, it helped hold the nucleus together, but the neutron, unlike the proton, had no charge, that after this discovery, suddenly it became possible to reason about the nucleus in new ways, and people began to wonder whether it was possible to make new particles beyond uranium, beyond element 92, beyond the nuclei with its 92 protons surrounded by 92 electrons. So that study became very important, and the group of Otto Hahn, another assistant Fritz Strassmann, and Lise Meitner were one of the competing groups desperate to figure out a way to exhibit these transuranic particles, these elements above 92 on the periodic table. What Hahn, Strassmann, and Meitner had been doing was to take a sample of uranium and to hit it with neutrons, these neutral particles. And the question is, what happened? What they assumed was happening was that they were building up somehow these nuclei into elements higher than uranium on the periodic chart. And if they were to knock a piece off, it would only be a small piece, so it would go down the periodic table by a couple of places. But no one imagined that you could break the uranium nucleus apart. You would either generate something a little higher or a little lower on the periodic table. Sort of like throwing a baseball at a house. Maybe you could get the baseball to stick on the house, or maybe you could knock a little chip off of the corner, but no one expected that you could throw a baseball at a house and have the house break in two. In July of 1938, Meitner finally realized it was impossible to stay any longer. She'd survived for 5 years under the Hitler regime in Berlin because she was a citizen of Austria, and since Austria passports were recognized as falling under a different set of laws, until Austria was annexed to Germany, she was somewhat protected. But once that had occurred, her life was in danger, and with the help of some physicists who were on her side, she was smuggled out of the country on a train, and after a very hair-raising moment at the Dutch border, she was admitted there and eventually made her way to Sweden. Well, Hahn wrote to Meitner, after Meitner was now in Sweden, this is December 1938, and said, "There is something about the radium isotopes that is so remarkable that for now we're telling only you." The isotopes of radium have somehow become enriched or changed their form in such a way that they're acting like barium. Now, this really mystified Hahn. He thought you could go down a little bit from uranium on the periodic chart, knock off a chip of it and get down to some form of radium. That made sense to him. But then when he started to analyze it chemically, it acted like barium. So Meitner, whom he trusted to really understand the physics, Hahn was a chemist, Meitner was a physicist, and Hahn said, how could this be? Is there any way that the barium could somehow get extra neutrons on it and start to act like radium? And Meitner said, no, that can't be. But that shows that Hahn really had no idea on the 19th of December 1938 what was going on. And he concluded by saying, if there's anything you could propose that you could publish, that it would be in a way as if it was work by the three of us. This sort of nostalgic note was soon to be contradicted. Meanwhile, Meitner was there in Sweden with one of her relatives, Frisch, and the two of them took a walk. December of 1938. There's snow on the ground. Frisch puts on his cross-country skis. Meitner just says, I can go faster just on my feet. And they began to walk through the woods, talking about this letter that had just come from Hahn. And as they began to debate this, they came to similar ideas. They each drew a different diagram, but gradually they realized it was the same. Frisch drew a kind of peanut, sort of narrow in the center and globular at the sides, where he pictured the nucleus kind of stretched out so that the different pieces of it, two pieces of it, were pulling at a smaller zone in the center. And then somehow, because there are concentrations of charge on the two ends of this barbell, they could fly apart. Meitner drew a circle with a dotted line circle inside it. And when they began to talk, they realized that Meitner had just imagined seeing the peanut essentially head on, with the dotted line represented the narrow waist of the peanut. Frisch recalled it this way.
Lise Meitner was in Sweden and was lonely, so I offered to come and visit her, and we met in the west of Sweden in a small place near Göteborg. And when I came, she was brooding over a letter of Hahn. And then we sort of kept rolling this thing around and saying, Barium, I don't believe it, there's some mistake. You couldn't chip 100 particles off a nucleus in one blow. It's fantastic, it's quite impossible for a single neutron to do that. And I still don't know how we got to the concept of fission, but I remember Lise Meitner drawing a dotted circle on a piece of paper and saying, couldn't it be this sort of thing? Now, she always rather suffered from an inability to visualize things in 3 dimensions, whereas I had that ability quite well. And I had, in fact, apparently come around to the same idea, and I drew a shape like a circle squashed in at 2 opposite points. And Lise Meitner then said, well, yes, that is what I mean. Apparently she had, so to say, looked at the nucleus from the poles on, and with the dotted line was indicating the equator being pushed inwards. And gradually we came to the idea that perhaps one should not think of the nucleus being cleaved in half as with a chisel, but rather that perhaps there was something in Bohr's idea that the nucleus was like a liquid drop. My recollection is that when I came back to Copenhagen, I found Bohr just on the point of parting, of leaving for America, and I just managed to catch him for 5 minutes and tell him what we had done, and I hadn't spoken for half a minute when he struck his head with his fist and said, oh, what idiots we have been, that we haven't seen that before. Of course, this is exactly as it must be, and he added, this is very beautiful, and had we written a paper? And so I said, no, we were in the process of writing one. I rigged up a pulse amplifier for the special purpose, and I also built a small ionization chamber, but that whole thing only took me about 2 days. And then I worked most of the night through to do the measurements, because the counting rates were very low. But by 3 in the morning I had the evidence of the big pulses. And I went to bed at 3 in the morning, and then at 7 in the morning I was knocked out of bed by the postman who brought a telegram to say that my father had been released from concentration camp.
So things had changed dramatically. Meitner wrote to Hahn on the 21st of December 1938, your radium results are very startling. A reaction with slow neutrons that supposedly leads to barium. In nuclear physics, we have experienced so many surprises that one cannot unconditionally say it's impossible. Later, Hahn claimed that Meitner tried to talk him out of fission. It was actually the other way around. It was Hahn who couldn't believe his results, and Meitner who had actually, with Frisch, figured out a way of understanding what was happening in physical terms by relating it to the liquid drop model of the nucleus. Hahn and Strassmann eventually published an article, No Meitner, that said, as chemists, we must actually say the new particles do not behave like radium, but in fact like barium. As nuclear physicists, we cannot make this conclusion, which is in conflict with all experience in nuclear physics. As chemists, we say we've made barium. As nuclear physicists, we say we can't agree. Well, maybe that was because Hahn wasn't a nuclear physicist and he needed Meitner to say that you could split it in this way. They published this, and it led to an international fascination. It was the greatest physics result in some years. It transformed the world. The effect of this fission discovery on Hahn and Meitner were very different. Hahn, in a sense, was rescued from being a bit of a suspicious character in the Third Reich to being a hero for having discovered fission. For Meitner, left out of the discovery and credit for it, her career was seriously endangered. She struggled from year to year, never received really the recognition of being part of those many years that led up to this experiment, or the person with Frisch who had actually understood what was happening from a physical point of view. In fact, the old work table was for many years memorialized as the place where Hahn and Strassmann had discovered nuclear fission. In fact, it wasn't their work table, it was the work table of Lise Meitner. It was the physics part of that experiment, and it was only many years later that the signs above the museum display of that discovery were changed to say that it had been discovered by Hahn, Strassmann, and Meitner. These discoveries quickly cascaded in work that was done in the United States and Britain by Bohr and his young colleague Wheeler as they crossed the ocean and developed a new theory of nuclear fission. It became the basis for a transformation in the way we understand physics, and it led in very short order to the creation of nuclear weapons programs in Germany and in the United States. We'll come to that next.